Welcome to More Learn, More Teach, where I attempt to simplify the complex. Today I'd like to talk to you about compounding. So in a previous lecture, we discovered that if I have a timeline and I have a constant APR, then if I have some value at zero, at the end of n years, I will have A0, whatever my initial value I put in, multiplied by 1 plus the APR raised to the n power. That's how much value I would have at the end of the period. So for an example, let's let A0 equal to $100. Let the APR equal to 5%. 5% divided by 100% is 0.05. So that's the number we will use in our equation. And let's go for 10 years. Using our equation, the amount of money I will have at 10 years is equal to $100 multiplied by 1 plus 0.05. That number raised to the power of 10, which becomes $162. So we have gained $62 over our investment. Now, at year one, I want to add an additional investment. So whatever I add in year one, that is going to grow for one less year. So my equation now at the end of the time, at time period n, I have B1, which is the amount I put in at year one, multiplied by 1 plus the APR raised to the n minus 1, because I put this money in 1 year into my total cycle. So if we let B1 equal to $100, using our equation, B at 10 is going to equal to $100 times 1 plus 0.05, that raised to the power of n minus 1, which is 10 minus 1, which is 9. That works out to $155. So if I had this investment strategy, A and B, A at 10 plus B at 10 is going to equal to $317 for a total investment of $200. So in general terms, if I add money at year K, some value D at K, then my equation for that chunk of money, how much that gets added to the total, is going to equal to the value that I placed in at year K multiplied by 1 plus the APR raised to the power of n minus K, because you have to account for the fact that you didn't put it in until year K. All right, so let's look at what the value will be on any given year for my investment. So I have some contribution that I'm putting in each year. At year 0, my total value is equal to the contribution that I put in at year 0. No growth has occurred yet. At year 1, I put in a contribution, but I also have growth from the previous year's contribution. So my total value is equal to the contribution plus last year's contribution multiplied by 1 plus the APR, or the growth from the previous year. In year 2, I have my year 2 contribution plus my year 1 value multiplied by its growth, which is 1 plus APR, which simplifies to the contribution of year 2 plus the contribution of year 1 multiplied by 1 year of growth plus the contribution at year 0 multiplied by 2 years of growth. If I go all the way to year n, whatever given year I'm talking about year n, the value at year n is going to equal to the summation from gamma equals 0 to gamma equal n of the contribution of year gamma multiplied by the growth, which is 1 plus APR raised to the power of n minus gamma. So this is to take into account the year that you're sticking it in there. If I put in the same amount every single year, so if I have a constant contribution, then I can pull this term out of the summation, and I end up with the value at any given year n is equal to my contribution multiplied by the summation from gamma equals 0 to gamma equal n of 1 plus APR raised to the power of n minus gamma. So now let's look at a negative contribution case or a withdrawal. So let's say I start with some principal value at time 0, and I'm going to start withdrawing at year 1. So the amount that I would have in this account is, on year 0, is the principal at year 0. The principal I'm going to have at year 1 is going to be whatever the growth was for year 0 minus my withdrawal at year 1. Or the principal at 1 is equal to the principal of 0 multiplied by 1 plus the APR minus my withdrawal. Carrying that on to year 2, the principal that's going to be there at year 2 is going to equal to the growth from year 1 minus the withdrawal that I take at year 2. So the principal at 2 is equal to the principal at 1 multiplied by the growth minus the withdrawal. Substituting in gives me this. And once again, I can simplify it in these terms. If I carry this on to year n, then the principal at year n will equal to the principal at year 0 multiplied by the total growth as if there were no withdrawals minus the summation of the withdrawals multiplied by the growth that was stolen from the principal, which gives me this expression here. If my withdrawal rate is constant, once again, I can pull the withdrawal term out of the summation, and I am left with this. Here's an example. Let's say that I have $10,000 in an account that has an APR of 5%, or let's say I borrowed $10,000 from somebody who has a 5% return on their investment. Then I want to look at how much I have to pay in order to pay this thing off or have a zero balance after 5 years. Then I have my equation, right, which is the principal at year 5 is equal to the principal at year 0, which is 10,000 in our case, multiplied by 1.05 raised to the power of 5 because it's in 5 years. That's how much this investment would be if there were no withdrawals. So if it was money that I had in an account at 5% interest and I took nothing from it, this is the amount that it would grow. If I borrowed that much money from somebody and I never paid it back, that's how much money it would grow in the 5-year period with that 5% interest rate. I have to subtract the withdrawal. So I'm withdrawing at a constant rate over a 5-year period. So this is my summation term, 1.05 to the 4th, to the 3rd, to the 2nd, to the 1st, and to the 0 power. All of that's going to equal to 0 in order to have the balance equal to 0, the principal equal to 0 at the end of year 5. So now it's just algebra. If I add this term to both sides, now I have a positive this term on this side, leaving this behind. Divide through by this term, and I have 10,000 times 1.05 to the 5th divided by the summation terms. Sticking it all into a calculator, I end up with $2,309.75. That's how much I'm going to have to pay every year for a loan, or how much I would be able to withdraw from an investment that was yielding 5% per year. This is how much I would get per year. Thank you for watching my video. Please like and subscribe. If you have any questions that I can help you out with, I'd be happy to try and answer your questions. Send me an email at morelearnmoreteach@gmail.com.